In this video, I'm going to build a real local multi-agent coding workflow in OpenCode. We will create a planner, a debater, an implementer, a reviewer, a tester, a linter, and a final agent that prints a commit message. And all of them will share context through one workflow file. OpenCode gives us the right building blocks for this pattern. We can define project level agents, choose which agent is primary versus sub-agent, configure model and temperature per agent, and set permissions per agent for editing files or running commands. So we are not building a separate orchestration framework here. We are using OpenCode's own agent system, then layering a workflow convention on top of it. I start with agents file, because this is where I put the global rules every agent should inherit. The goal is to make the workflow consistent. So all agents know they must read the workflow file. Here you can see that I define all agents participate in one workflow, read workflow state file before starting the work, update the workflow state file before finishing the work. This is very important. And the workflow order also as follows. Planner start with clarify the request and then plan. Debater will critiques the plan. Implementer start making the change, and then so on. Writing rules to avoid hallucinating. Keep entries short. Prefer bullets over paragraph because later on we want to read that workflow state file and realize or see what AI did and why. And shared workflow rules also important in this file. All agents must use workflow state. Again, I mentioned this because this is very important for our workflow. Before starting, read workflow state. After finishing, update only the sections relevant to your rule. This is the workflow state file. As you can see, there are multiple sections, and each agent must only update the section that's relevant to itself, not the section related to others. And last but not least, when working on a code, dependency, or libraries, use Context7. Context7 is an MCP that I already set up for my OpenCode. So my agent, instead of hallucinating about the library or dependency behavior, it will query the Context7 to get more information. And again, do not use chat history as the only source of truth. This is very important. Workflow state is the canonical workflow record. Next, I create the shared state file. This is what lets agents talk to each other in a controlled way. You can extend this over time, but this is a solid minimum. It captures the whole without becoming too noisy. Let's create our first agent, Planner. The Planner is the most important agent. I don't want it to jump straight into implementation. I want it to clarify the request first, ask questions, confirm a scope, and only then create a plan. So let's start by defining our plan. For the description, I want the planner to clarify the request first and then create a plan and hand over to the next agent. Planner needs to be primary because this is the main agent that we talk to. I also want to define the planner model. Why? Because I want to use different model for different purposes. First reason for that is to maximum the creativity, and the second one is the cost. For example, we will create commit message agent in a moment. This agent is not very important, so we can use a cheap AI model to do not spend too much money or too much premium token over that simple job. But planning is an important job, so I want to use one of the best model that I have access to it to do the planning for me. I use GitHub Copilot, but you may not. So how are you going to find the model name? As you can see in the OpenCode documentation, you can already see that For example, to use anthropic models, you need to provide the provider name and the model name. How are we going to find this? If you scroll down here, you can find the structure in the model section. The model ID in your OpenCode config use this format, provider/model ID. For example, if you are using OpenCode Zen, you would use OpenCode / the model name for GPT 5.1. So now I'm using GitHub Copilot, but I still need to find the model name. For the model name, I go to model.dev website and then search for Copilot or GitHub Copilot. As you can see, it listed all the model available via GitHub Copilot subscription. And for the planner, I want to use GPT 5.4 as a model ID, and the provider is also here, so GitHub-Copilot. So my model name will be GitHub-Copilot / GPT 5.4. The next important part is the permissions. As I said, I don't want my planner to jump straight to coding part or implementation phase. I want planner to only do the planning for me. Therefore, I need to give the planner a set of permission. First of all, the planner does not allow to edit any file. If it wants to edit any file, it should ask. But planner is allowed to change or edit the workflow state file. The workflow state file is our shared state between the agents. So this is important. Also, planner can run bash command or web page in order to gather information or check the code base. Then I will define a set of tasks for the following agent. I also want to add a few description to the planner. I will define the rules so the planner will stick to the rules and won't start hallucinating. First of all, I will define the shared state rules. It's basically the same as I wrote in the agent file, but a bit more specific for the planner. Then I will define the workflow for the planner. So the workflow is strict. Phase 1, clarify. Phase 2, confirm understanding with the user. Phase 3, start planning. And phase 4, hand over to the debater. Debater, review the plan before starting the implementation. Last but not least, I define a set of rules. Never make code changes outside workflow file. Do not hand off until requirements and acceptance criteria are clear. And also prefer 3 to 7 high-value clarification questions over many low-value. Our next agent is the debater. The debater is not a generic critic. His job is very specific. Review the planner's proposed plan and decide whether a better plan exists. I'll start by defining the debater. You can see here I use Sonnet 4.6. For the planner I'm using GPT 5.4, but for the debater I want to use a different model. I can also use Opus, but this is a trade-off. Later we can swap the models to analyze the performance, but for now I use Sonnet. The same permissions as the planner, but no more tasks because the debater only talks to the planner, not the rest of the agents. And for the description part, I redefined the shared state rule. Also add a specific part for the debater, so must read the request, clarify the scope, constraint, and acceptance criteria, plan and files to change from the workflow state. So the planner will fill out these parts for the debater and decide whether the current plan is reasonable as is or whether a better plan exists. So that's what debater must do. And then evaluate the plan for unnecessary complexity. So reduce the complexity, missing steps if needed based on the request, scope, and constraint. fix or evaluate the incorrect assumption. Maybe the planner hallucinates some part of the request. Find the hidden edge cases. Backward compatibility risk. This is very important if you are adding a new feature for a specific design or you're defining a new API. Define whether are there any missing tests or validation in the plan. And also check the performance, security, or maintainability concern. And if you find a better plan, explain why the current plan is weaker. This is very important for us, that later we will review the work state file and we realize that why debater suggests an improvement or change to the plan. Propose the improved plan and state exactly what should change before implementation. This is also very useful for the planner to know how to or where to update the plan for the implementer. If the current plan is already good, explicitly say that no better plan is needed. Again, this is for us for later investigation, and explain why it is acceptable. Write your output into work state file, the debate note, current status, and next agent. The debater will write the result under this part. This is one of the most important design tricks. Narrow prompts produce better sub-agents. Next agent is the implementer. The implementer is the only agent I usually give broad edit access to, because this is the agent that actually changed the application code. For the implementer, I use GPT 5.3 codex as the model. It's usually good to swap them over the time and compare the performance. The implementer also has the permission to edit everything, also use batch and web page. Now the description for the implementer. You are the implementer. Read workflow state before starting. Your job is to implement the approved plan from workflow state, so it's not going to hallucinate and do some random implementation. It will follow the plan that already mentioned and approved by the debater in the workflow state file. Make the smallest change that satisfies the acceptance criteria. So avoid unrelated refactor or unrelated change and only focus on the acceptance criteria and do the small change. And then record the files change and short implementation summary in the workflow state file. Set the next agent to reviewer and ask reviewer to review. This part is also important. If the agent is blocked, do not guess, and write the blocker clearly in the workflow state under current status. And then planner will ask a user to resolve the blocker if the planner cannot resolve it by itself. So these agents get power, but it also get constraint. Smallest useful change, no unrelated refactor, and always write a handoff. Now I add the rest of the pipeline. These agents are all about narrow and reliable responsibility. The next one is the tester. I use GPT-5 Mini because the tester only responsible to run my test command. In this project, I'm using Bazel as a build system. In the permission, I said that the agent is allowed to run Bazel command. And also, I explain here that run Bazel test. This will run the entire test module, report commands, and pass failure status in the workflow state file, and determine whether failure are caused by the new change if it's possible. And then write the test result, current status, and set the next agent. The next agent is the reviewer. I use GPT 5.3 codex as the reviewer, and the reviewer also only allowed to edit the workflow state file. The reviewer will check the implementer code and review the code, review the finding, add the finding to the workflow state. If the implementation is acceptable, set the next agent to tester. If not, ask the implementer to fix the comments. and give the precise fixed guidance to the implementer. So the next agent in my workflow was the tester. I by mistake explained the tester first, but this is the order that you can also choose on your own and choose what or which one is the best for you. The next one is Linter agent. For the Linter, I use GPT-5 Mini because Linter responsibility is to only run a Python script. This is not something very special. I can use a cheap model, GPT-5 Mini, and the Linter try to write the results in the workflow state. If it is acceptable, set the next agent to the commit message. If it's not acceptable, set the next agent to the implementer. So implementer will fix the issues for us. And then it will come again to the tester and the linter to check the code again. And the last agent is the commit message agent. I use GPT-5 Mini again for this agent because there's nothing special. This agent will check the Git status, use the Git diff and Git log to identify the changes and then generate meaningful commit message for us, and will print or add the commit message to the workflow state. When user is checking the workflow state, can copy paste or get some idea about the commit message and use the commit message for commit and push everything to the repository. Now workflow is complete. Each agent knows exactly what to do and what file to read and what section to update. Let me pause here because permissions are what make this safe. The reviewer, debater, tester, commit message, and linter agents are only allowed to edit workflow state file, while the implementer can actually modify the code. And because the workflow file is at the root of the project, this kind of rule works even though the agent file are inside the OpenCode agent folder. OpenCode supports path-based edit permissions, and the specific workflow file rule can override. I also assign different temperature per agent based on the job. Planner, reviewer, tester stay low temperature because I want consistency. Debater get a slightly higher temperature because it needs to challenge the plan. As I said before, you can keep one model everywhere to start. Then later mix a stronger and cheaper model by rule. I will give the planner a feature request and watch how it works. Here is my command that I want to give to the planner. I want to implement Firebase authentication and implement the login button in the setting tab. Let me run OpenCode. As you can see, OpenCode already has two agents, build and plan. When I tap again, it will switch to my new agent, planner. And then here I paste and then hit the. Let's also watch the workflow state file and see how planner will start working. First, it starts with clarifying a question and update. If there is any clarifying planning process, finding the Firebase documentation. Here is the request. There are some questions and the constraint. Let me answer the question. This is exactly what I want to have. First clarify the request, ask the question, and then start the planning. So I answered the question and let's see how the planning will goes. I can also show the workflow state file. As it changed, it identified the modules and the file that need to be changed. Confirming Firebase setup, update the workflow planning file, searching for the Google service info file, which already found, finalizing workflow steps, planning the next step. So we should see the file update very soon here, reading the workflow state, and here we go. So acceptance criteria listed here, finding from the Context7, and the current status. Soon it will start the planning, and here is the plan. Then it asks debater to review the plan. You can also, if you click here, you can see the debater status. Use Sonnet for the debaters. It start reviewing the plan and the file, and here in the workflow state the next agent is the debater, so debater is working on the plan. And again, notice how the workflow file becomes a trace of the whole development process. And if something goes wrong, I can inspect the exact handoff state instead of trying to reconstruct it from the memory, which is not easy to do, especially with lots of logs and the findings from the output. So the workflow state file is a source of truth, and I can review the file in the future and exactly identify where and what went wrong. And as the agents are working, let's say the reason this setup works is that we combine three ideas: a specialized agents for each roles or each task, a shared workflow file which agents can communicate to each other via that shared workflow file, and also user can review that file later, and strict permissions, so only the implementer has the permission to change the code, not any other agents. Without shared state, agents handoff are fragile because they rely on the memory, which is not a good place to hand off the information or the task. And without permissions, they are risky because any of them can go and touch the file. And also, as I'm using a different model, for example, for the tester or the linter, I'm using a cheap model. I don't want that cheap model actually goes and change anything in the file. I only want them to run a specific job or task for me, and then hand over to a better model to do the job. And without role separation, they become noisy and inconsistent. And this is also extensible. Later, you can add a security reviewer, a documentation writer, migration planner, or release notes agent without changing the whole system. So you can add a new agent or sub-agent to the workflow and improve that workflow based on your requirements. The debater now finished. We can see that adds lots of information here. Now the planner is preparing the patch based on the debater comments. Added the file needed to change. Let's see, soon Implementor will start the implementation. The next step is Implementor. The Implementor start the implementation. That's my full OpenCode agent workflow. A planner that clarifies the task first, a debater that checks whether there is a better plan, an implementer that writes the code, and the rest of the agents handling the review, testing, linting, and the final commit message for me. If you end up trying this in your own repository, tell me in the comments. I'm curious how you structure your agents, your shared state file, and your permissions. And if you are interested in part 2, write that in the comments as well. In the next video, I will show how to add a security reviewer and how to mix local and hosted models per agent for a more practical setup. Thanks for watching.